So today's topic is ABCs. Okay? We have already gone through the basic topics uh, of this subject, which is digital electronics, in which we went through the counters, right? Basically, we started from flip flops and there on we went to counters. काउंटर्स में हमने अपने बेसिक जो काउंटर्स है कहा कि दो टाइप के होंगे. Just a slight recap before we move to ADCs. We said that we will have two types of counters. One is synchronous, another is any one of you. Another is
Asynchronous.
asynchronous. Exactly. We did some types of the synchronous counters and we did some types of the asynchronous. हमने कहा asynchronous में एक basic counter देखा हमने, इसी तरह synchronous में भी एक basic counter देखा. And from there on, now we are moving towards, I think we saw different flavors or different counters, serial carry, parallel carry, all of these counters, and then we saw parallel, all in one register. Did we see that also? Or which we called as dual register. Right? We saw this. So now we can move to the next topic. I want students to answer करना जरूरी है. Anyone? हमने ये topics देखे ना, bidirectional register. Anyone? Saqib?
Yes.
Or Sirat? Anyone? Saqib?
Yes, sir.
Okay, you be with me and you will respond continuously. Because one student should at least respond so that we feel that class is alive. Okay? So now we move on to another topic which is known as ADCs. So what is an ADC? ADC is analog to digital converter. Is this visible? Students, I am trying my level best actually to make that experience exactly as if we are in class. So we will also try to see how we can make notes also. And let's hope you all will cooperate. So what do we expect in an ADC? In an ADC, we have, let's say, a block wherein we give some analog voltage value, say for example, an analog value, and it will convert this analog into some digital value. So the function of an ADC would ideally be defined as that an ADC converts an analog voltage into a digital value or analog value into a digital value. And this analog voltage will have some value, whereas this digital will be, say, be converted into n bits, or it will be represented by some number of bits. I think I don't need to define this operation to you. You know this operation already? मतलब ये आपको पता है ना कि एनालॉग टू डिजिटल कन्वर्टर का काम क्या है? आप सबको ये पता है ना? Yes, please. I need an interactive class, beta. Either, yeah, you know the definition of, or you know the purpose of converting analog into digital? Anyone with the idea or with the purpose? Why do we convert analog signals into digital?
Yes, sir.
Because digital signals are easy to process.
Absolutely correct. Digital signals are easy to process and easy to store also, right? We, for example, we have a subject dedicated for digital signal processing. That digital signal processing comes into existence only when you have digital signals, right? So what we do in that, we have an analog signal, we convert, or say, for example, we have an analog message signal that is to be transferred to something, or that is or some receiver, or that is to be stored in some place. So we convert it to digital form and extract the various features or information from that particular message. So that is possible only when we have digital signal. So that is how we understand the need of digitizing an analog signal. So first, before moving to the topic of ADCs, we should try to understand that what is the need for this digital signal. So one is that maybe in the field of communication, that we are able to process them, or we can do a vigorous processing. And there's a subject you will later on in this or next semester, you will have by the name of digital signal processing, and that subject itself is dedicated for this digital signal processing itself. This is one. Another is that in communication, we have so many techniques which are known as digital modulation techniques. So they are possible only when we digitize the signal, and also we see the storage of these signals is easy. So the advantage of you can take this as a note, or you can uh, take this as a small assignment for your own self. Advantages of digital signals over analog signals oblique systems. Okay, so कोई भी सिस्टम की जो एडवांटेज होगी डिजिटल सिस्टम की, वो तभी पॉसिबल होगी जब हमारे पास कोई डिजिटल सिग्नल है, राइट? So an analog to digital converter will convert an analog value into some digital bits. Let's say हमने designate किया with n bits. Now the first and the foremost thing is what are the different types of analog to digital converters that we will see in near future. So the first one over here is counter type ADC. The second type over here is successive approximation register type ADC. I am saving space because I don't have much space available to write. So, but listen to me, please. Is everyone able to listen to me very clearly? किसी को voice में lag तो नहीं आ रहा है?
No, it's clear.
Fine. So SAR would mean successive approximation register. So you can write successive approximation register type ADC. इसका आप full form लिखेंगे, ठीक है बेटा? Third type is can you read this for me, please?
Flash.
Exactly correct. Flash type ADC. So that means it's very clear. Fourth one is dual slope type ADC. लिख दिया आपने? Are you done? Well, I want every one of you to take a pen and paper and note down as if we are in a class. Okay? सबने notebook निकाली है. I want you to take a pen and paper immediately. Those of you who have not taken, given that is not the right approach. Then पैसे वापस नहीं मिलेंगे. खाली उसी को मिलेंगे जो पेन एंड पेपर लेके हैं इस टाइम और फॉलो कर रहे हैं, ठीक है? तब जाके उसको कुछ समझ नहीं आया, then that is the option. Anyways, this is called as ADC. Shall I erase this?
Yes, sir.
Okay.
Yes, sir.
Nice. I want interaction. That is pretty good. So obviously when we have analog to digital converters and we feel the need of converting an analog signal into digital signal, there is also a need to convert a digital signal to analog signal. Can anyone among you tell me why there is a need to convert an analog signal, sorry, a digital signal back into analog signal? Very
Because
quickly.
analog is exact.
Analog signal?
Is exact.
Okay, one. Another.
So implicit is left.
You can say a longer answer, please. Can you just continue again?
So in case of analog signal, each and every bit of information is transmitted, nothing is lagged in between.
Yeah, you're right. That is fine. But when we transfer it completely as analog, but when we convert something into digital, there is a permanent error called as quantization error. ये आप याद रखिएगा, we'll discuss it later on. So there, this may not happen exactly, but then yes, there is a need to convert every digital signal back to analog. Can anybody else tell me or add to what she has already said? Nice example. Why do we need to convert things back into analog form? Mavish, can you tell me? Come on, just a random try. Are you there online or not? If you're not answering, I'll consider that you're not there. You have 3 seconds to respond. Okay, that means you're not there. So, Sirat, can you tell me? Come on, anyone else? Okay, Saqib, can you tell me? What do we need to convert signals back to analog form?
सर मुझे नहीं पता.
Okay, good. Anyone else? Okay, let's leave it to this. So there is a need, and why I'll tell you in a while. So there is a need to convert a digital signal back into an analog signal, and that is done by a DAC, digital to analog converter. So in a way, this is a brief introduction of a digital to analog converter that will convert these n bits back to what? Analog voltage VA. And now why there is a need? Yes?
आपकी आवाज lag हो रही है.
Okay. So now I'll just try again. I'll repeat this. So we convert this digital signal back into the analog signal because there is a need to convert this digital signal back into analog. The reason for that is because nature is analog and we understand analog. For example, if I have digital voice, it is digitized, it is in the form of zeros and ones. Now when that digital voice is given to a recorder, it converts, processes, and just beautifies it. But what is the final output? Is final output something, a device other than speaker? No, it is a speaker. The speaker converts those digital signals into vibrations of the drum. That vibrations of the drum actually vibrate the drum of my ear and I hear the sound. So this is analog again. The conversion of that digital signal back to analog, which is given as a voltage to a speaker, and those different voltages vibrate the drum of that speaker in different ranges, and that's how I hear different sounds. Are you getting my point? Is that okay?
Yes,
Human
sir.
eye is an analog camera. Is human eye a digital camera or analog camera? Human eye
Analog.
is as good as an analog camera. Okay, you're getting my point. So we can see colors, I would say in a way, in analog, or this is the analog way of seeing colors. So unless and until a picture which is digitized is not converted back into analog form, maybe I cannot see that. You're getting my point? So there is a need of converting these digital signals back to analog. So we must study also digital to analog converters. And what are they? We have a few examples of digital to analog converters. One is weighted. Can you read this please for me? Can you read these two for me? Any one of you?
To all
Weighted resistor DAC and R2R ladder DAC. That is digital to analog converters. So these are the two types of digital to analog converters we may see as we move on. Okay, now let's take up, what's the time by the way? Can you tell me the time please?
8:30.
8:30, because I want to be very brief with this class. We may finish in about 10 to 15 minutes, okay? At the max, 10 to 15 minutes. So let's move on with the first type of ADC, okay? क्योंकि पहले एनालॉग सिग्नल है, हमें सीखना है कि उसको डिजिटल में कैसे कन्वर्ट करें. So what was the first type of ADC?
Counter type.
Exactly right. Counter type. Because देखिए मैं इस तरह से कोशिश कर रहा हूँ पढ़ाने की, so that आपको यहीं पे तैयार हो जाए एग्जाम के लिए. अच्छा? Because we don't want to waste time. We want to ensure that we get the most of this. So first type of analog to digital converter is your counter type. So first thing first, let's make a simple block diagram that will help us to understand what are the various blocks in a counter type ADC. So let this be an this be an operational amplifier. We provide this output to an AND gate, which has another signal by the name of clock. This AND gate gives its output to a up counter. The up counter generates a certain count sequence, right? This is given to a DAC, that is digital to analog converter, and that gives this signal back to the operation amplifier. I'll help you to understand these blocks one by one. You please draw this. So, आपने operation amplifier पढ़ा होगा already, right? ऑपरेशनल एम्पलीफायर आपने पढ़ा है?
Yes, sir.
राइट. ऑपरेशनल एम्पलीफायर का सिंपलेस्ट ऑपरेशन ये है कि उसके जो दो इनपुट टर्मिनल्स है, अगर एक पे हायर वोल्टेज रखते हैं दूसरे पे लोअर वोल्टेज, इट इज यूज्ड एज अ कंपैरेटर. इट टेल्स अस कि इन दोनों टर्मिनल्स में वोल्टेज सेम है डिफरेंट है. अगर डिफरेंट होगी तो वो लॉजिक 1 देगा आउटपुट पे, राइट? ऐसा होता है ना?
Yes, sir.
So you like, have you drawn the diagram? Diagram visible है clearly?
Yes, sir.
Please draw it very quickly. So where VA is the analog voltage, this is your operation amplifier, or you can say that this is the comparator. You can say this is comparator. This is your AND gate. It is visible anyway. This is your up counter. It is written already. And this is your digital to analog counter. So how many modules? 1, 2, 3, 4. So in our first type of the ADC, हमें क्या करना है? Analog को digital में convert करना है. But we are seeing that it has 4 blocks. So the first thing that अगर इस type का question आता है, explain the operation of a counter type ADC. The first thing in which you should explain is that it has following blocks. The first block being the comparator block, followed by an AND block, an up counter, and a digital to analog converter. A simple digital to analog converter. So first point लिखिए आप. In a counter type ADC, a comparator is used as the first stage to compare input analog voltage. Are you writing, or shall I help you to make notes, or you will shall I be very fast in explaining the operation? Yes? Shall I help you to make notes, or shall I be very fast in explaining the operation of all these blocks? I want the answer from you, please.
Sir, help in making notes.
Okay, fine. Continue then. Anyone else with some different opinion? Okay, you can write. In a counter type ADC, a comparator is used. Was this Irtika?
Yes, sir.
Okay, you can keep your mic on if you're in a normal surrounding where there is no noise. Okay, so in a counter type ADC, a comparator is your mic on, Ritika?
Yes, sir.
So you just be with me and so that I come to know how much you are done. In a counter type ADC, a comparator is क्या लिखा आपने जरा आप पढ़िए?
In a counter type ADC, comparator is used as a first stage to compare input analog voltage.
Input analog voltage with reference voltage provided by digital to analog circuit. Okay, क्या हो रहा है? यहां से एक रेफरेंस क्योंकि ये सर्किट क्या है डिजिटल टू एनालॉग और यहां से इसको डिजिटल बिट्स आ रही है तो ये डिजिटल टू एनालॉग है ऑब्वियसली इट विल जनरेट सम say VAR which will be the reference voltage. So VA and VAR will be compared and based on the value, say if VA is higher than VAR then it will continuously enable the logic AND gate. वो क्यों कर रहा है वो हम देखेंगे. So then the next line is यहाँ पे लिख लीजिए if analog voltage is higher than the reference voltage, the output of the comparator will enable the AND gate if the analog input voltage or if VA is higher than the reference voltage, the output of comparator will enable the AND gate
Reference voltage.
is greater than the reference voltage, comma, the output of the comparator will be logic 1, will be logic high. The output of the comparator will be logic high. Comma, which will enable, this logic high signal will enable the AND gate such that the counter continuously counts the clock pulses. Because अगर आपको याद होगा हमने क्या कहा था काउंटर का काम क्या होता है क्लॉक पल्सेस को काउंट करता है तो इसको बस चाहिए काउंटर को कि क्लॉक पल्सेस कहीं से आ जाए जब तक मेरा एंड गेट डिसेबल होगा काउंटर को कोई क्लॉक पल्स मिलेगा यस और नो जब तक मेरा एंड गेट डिसेबल्ड होगा डिसेबल मतलब उसका कोई एक इनपुट जीरो है तो क्लॉक्स आ रहे हैं दूसरे पिन से क्या वो आउटपुट पे क्लॉक पल्सेस देगा कंटिन्यूअसली नहीं देगा क्योंकि एंड गेट क्या है डिसेबल मींस उसका एक पिन जीरो है तो एक पिन जीरो होता है एंड गेट में व्हाटएवर इज द अदर पिन द आउटपुट इज ऑलवेज कम ऑन रितिका
Sir, 0.
So be with me please students every one of you has a responsibility to answer so just open your mic and answer teacher don't think anyone else is answering ऐसा मत सोचो कि वो करेगा ये करेगा do it for your own self think that you and me are the only two students only two people in this classroom so don't think anyone will answer मैं साइड में रहता हूँ यार so answer for your own self okay so this enables the AND gate and the clock pulses are applied to the counter therefore the counter up counter is used to count the clock pulses applied through the AND gate therefore the up counter is used to count the clock pulses applied through the AND gate
Sir, repeat कीजिए.
Therefore the up counter is used to count clock pulses applied when conversion is started. Okay, therefore the counter is used to count the clock pulses applied. बस full stop कीजिए वहाँ पे. उसके बाद देखिए full stop. When conversion is started, the counter by default is resetted to 0 first. When the conversion is started, the counter by default is resetted to 0 first. Okay. So is the quality better now? Or it's all the same?
It's the same.
Okay. So, कहाँ पहुंचे हैं? Okay, now go to the next paragraph. When applied analog voltage is greater than the reference or feedback voltage, the output of the comparator being logic 1 results in incrementing the count in the counter. Yeah, results in incrementing the counter. समझ रहे मेरी बात? क्या मैं बोल रहा हूँ? जब तक आपको हाँ समझ रहे मेरी बात?
So it
results in incrementing the counter count. Results in incrementing the counter count. Results in incrementing the counter count. This increment continues as long as VA remains greater or equal to the feedback voltage VAR. Okay? So this incrementing continues. Are you writing? Everyone is writing? Yes or no? Answer for your own selves, please. Everyone is writing? Yes or no?
Yes,
Yes, sir.
Okay, good.
So that means V reference should be equivalent to VIH. That is the minimum input voltage and gate for which the output of logic will be 1.
I'm saying VAR is greater or equal to. Sorry, VA is greater or equal to VAR. So the output will stay as logic 1. You're right. So the moment, now you can write, when the analog voltage will become less than the feedback voltage, that is VAR, when the analog voltage will become less than the feedback voltage, the output of the comparator will become logic 0. So when the analog voltage, or I would say actually what is happening is that the reference voltage has become greater than the analog voltage. Analog voltage तो static है, वो तो हमने change नहीं की. Maybe to write the same thing again, it is better to write when the feedback voltage becomes greater than, the moment feedback voltage becomes greater than the analog voltage value, the output of the comparator is logic 0. and counter stops. Yeah, counter stops at this particular count. Logical? कुछ नहीं हो रहा है जब तक यहां से 1 आ रहा है, एंड गेट एनेबल्ड है, जितने भी आपके क्लॉक पल्सेस है वो आगे जा रहे हैं, एंड ये काउंट कर रहा है 0, 1, 2, 3, so on, 10. The moment this comparator supplies a 0, now whatever is the input on this side, anyways AND गेट का आउटपुट हमेशा क्या रहेगा? 0 रहेगा, तो काउंटर फर्दर काउंट नहीं करेगा. क्यों? क्योंकि उसको कोई क्लॉक पल्स मिल ही नहीं रहा है. रिसेट भी नहीं हो जाएगा, लेकिन आगे भी नहीं चलेगा. सो द काउंटर सीज और द काउंटर स्टॉप्स. आर यू विद मी? आर यू राइटिंग विद मी? So at this time, at this moment, the output of the counter will provide the corresponding binary number. Yeah, will provide the binary number. At this point, the counter will provide the binary number corresponding to the analog input voltage. Okay, at this point of time, the counter will provide a binary number corresponding to input analog voltage VA. Is that clear? So इस point पे suppose हमारा number अगर है 1010, so 1010 is what actually is the digital equivalent of your VA. Suppose आपने VA रखा था 10 volts, for example. So then it is 1010, therefore your analog voltage, या ये जो number है ये कॉरस्पॉन्ड कर रहा है टू योर एनालॉग वोल्टेज, टू योर एनालॉग इनपुट वोल्टेज. इज दिस थिंग क्लियर? आपको क्लियर हो गया? तो हम क्या करेंगे, यहां से टैप इन करेंगे कुछ कनेक्शंस, एंड वी विल हैव आवर, से if this had been only 4 bits, so we have our respective number, and this is N0, N1, N2, N3. So these are the 3 bits. So your number is N3, N2, N1, N0 is the digital equivalent of your analog value. समझ आ गया बेटा? Anything that is not clear? इसमें एक और पॉइंट लिखिए. For n-bit counter type ADC, for n-bit counter type ADC, for n-bit counter type ADC, maximum number of clock pulses required is 2 raised power n minus 1. ताकि ये maximum count करे. For n-bit counter type ADC, maximum number of clock pulses required is 2 raised power n minus 1. Point number 1. दूसरा point इसी में लिखिए. मैक्सिमम कन्वर्शन टाइम, ये इंपॉर्टेंट पॉइंट है. दिस इज इंपॉर्टेंट पॉइंट, हैश मैंने लिखा है यहाँ पे. आर यू विद मी? आप सुन रहे मेरी बात बेटा?
Yes, sir.
सो मैक्सिमम कन्वर्शन टाइम इज इक्वल टू 2 raised power n minus 1 into t clock. दिख रहा है आपको ये? Can you see this right extreme?
Sir, yes, दिख रहा है.
क्या लिखा है यहाँ पे?
CLK.
TCLK. That's nice. So I think इसका मतलब हमारा स्क्रीन जो है सही जगह पे सेट है. So maximum conversion time is 2 raised power n minus 1 because numericals इस पे आ सकते हैं. So we have a counter type ADC. What's the maximum conversion time? This is the conversion time. So obviously, minimum number of clock pulses required to count is obviously 1. The minimum number is 1. Minimum number of clock pulses required to count is 1. Therefore, average clock pulse क्या हुए? Average clock pulses required is equal to, इन दोनों का sum divided by 2. इसका और इसका sum. Eyes on board please. Listen to me. This is an important point. So the average clock pulse is required for a counter type ADC. इसको क्यों counter type बोलते हैं? Anyone please? Mavish, can you tell me? If you are back there, this is your last chance. Otherwise, you will be marked absent. Mahesh, can you tell me? इसको काउंटर टाइप एडीसी क्यों हम कह सकते हैं? सीरत, are you there? सीरत, are you there?
Yes, sir.
Okay, इसको हम काउंटर टाइप क्यों कह रहे हैं? Any idea?
सर इसमें अप काउंटर यूज हुआ है.
बल्कि हाँ, राइट, दैट्स वन. अनदर इज कि क्लॉक पल्स को काउंट कर रहा है कंटिन्यूअसली, दैट्स व्हाई. एंड टेल योर फ्रेंड दैट यू आर एब्सेंट. Okay, so the average clock pulse required will be 2 raised power n minus 1. Rule number 1, are you there? Rule number 1, are you there? Zahan, are you there? Zishan, are you there? Sami, are you there?
Yes, sir.
Okay.
Yes, sir.
Zishan. Zishan, आप सुन रहे हो?
Yes, sir.
Is it Zishan or Sami?
Zishan.
Okay. So are you there from the beginning of the lecture or not?
Yes, sir. पहले से हूँ.
Okay. So why do we call this as counter type ADC? Yes, Zishan. Any idea, Zishan? Why do we call this as counter type ADC?
No, sir.
So that I can guarantee then you were not exactly from the beginning or you were missing somewhere in between, because this is a simple question for your level. बीच में आप गायब होने की जरूरत नहीं है. Please be there. ठीक है? Maybe you were there right from the beginning, but you might have missed some portion. Have you missed some portion?
No, sir.
Then what are you not able to answer? Counter type ADC इसलिए इसको कहते हैं because इसमें हम क्लॉक पल्स को काउंट करते हैं और जो काउंट निकलता है वही हम कहते हैं जी वही है आपकी एनालॉग जो इनपुट आपने दिया था उसका इक्विवेलेंट वही है, इसलिए इसको काउंटर टाइप ADC कहते हैं. Anyway, so the average clock pulses will be equal to 2 raised power n minus 1. So the important point, the last point, and with that we'll close today's lecture, is that what's the time, by the way?
8:52.
8:52.
Okay, we'll just finish in 1 minute. So the last type of last point over here is that in counter type, ये आप लिखिए इसमें, ये बहुत important point है. In counter type ADC, conversion time varies.
सर ब्लर आ रहा है.
Okay, just listen to me. In counter type ADC, the conversion time varies with input analog voltage. Analog voltage or value. Okay. इसका मतलब अगर मेरा छोटा वैल्यू होगा तो कम टाइम लगेगा, अगर मेरा बड़ा इनपुट वैल्यू होगा तो ज्यादा टाइम लगेगा. यही है उसका मतलब. क्योंकि हो सकता है कुछ ऐसे एडीसीज हो आगे जिसमें एनालॉग वैल्यू का बड़ा होना छोटा होना मैटर ही नहीं करता. आप समझ रहे मेरी बात? गेटिंग माय पॉइंट? सो दिस इज इन अ वे अ ड्रॉबैक. सो ड्रॉबैक ऑफ दिस टाइप ऑफ काउंटर इज दैट in, yeah, मत लिखिए drawback, just write a simple point. You will decide whether it's a drawback or not later on. So in a counter type ADC, the conversion time varies with the input analog
Value, yeah.
value of voltage. Exactly that. So it is, last point, it is a slow ADC. Counter type ADC is a slow ADC. That is the end of today's lecture, and we'll mark the attendance now. Tomorrow we will see another type of the ADC and we'll continue like that.